welcome everybody. And I think I may have mentioned it before, but I'm Kristin Burrus. My contact information is at the bottom of the page. I've also have a little QR code and a bit.ly, and that's on several other slides too. So don't think you have to go super fast, but if you do want to follow along, or I've added links to the slideshow, please feel free to jump on that bit.ly. But just to introduce myself, I do teach in Hamilton County, and I've worked with Michael for over a decade. I really think that that's a true statement. I've been a public school teacher. This, I believe, is my 22nd year of teaching. I started as a science teacher in 7th grade, 9th grade biology, anatomy and physiology. I taught all over the science department, and then started getting interested in technology. And I think part of that was the beauty of teaching middle school. If anyone else teaches middle school, is that you get to teach a little bit of everything. And so I started really enjoying the time I spent with students doing engineering projects and things like that. And that's sort of where all this came from. So when 2017, Michael mentioned there were applications to get a Fab Lab for your school, I ran to my principal and said, not only will I help you write this proposal, but I want to be it. I want to be the person that's in this Fab Lab. I just can't imagine anything more fun. So anyway, so that was my plan. And then several years later, I just have to say this, Taylor and Jamie were my students in 9th grade. I did not know that they had both gotten into the engineering program until today. And so I'm super excited and proud. You know, someone wrote sniff, sniff in the chat, and I'm like, yes, it almost brought me to tears. I'm so proud of them. But anyway, but now this is where I teach. This is the Global Center for Digital Innovation. It is a very fancy room on a community college campus, but I am a K-12 teacher. So we have the STEM school is connected. If you look at the darkness of the warehouse to the left in this picture, the STEM school is that direction. And then my students from STEM, and then also students from around the county come to this fabrication center. This was us a year ago. It was a big giant mess and a giant room full of boxes. And then this was us in August. So we do a lot of teacher PD. Michael mentioned we have 36 labs in the county. All those teachers do quarterly PD at the GCDI. That's what I call it because it's a mouthful. And then we also have elementary students, high school students coming through. So I wanted to, talking about content PBLs and maker projects, I wanted to start with just some examples from the last 5 years of me teaching, and then we'll talk about the how-to, right? So I just want to show you what we've done so far. And I kind of why not? Start in kindergarten. So one of my favorite PBLs was the students making safety gear for Humpty Dumpty. Most of you guys will know this as an egg drop. However, we made it a more inclusive PBL because we read the book After the Fall. It is precious. If you've never read it, please do. And then the students made safety gear for Humpty because he gets brave and he climbs back up the wall, right? So we wanted him to be safe. This was an amazing maker project. The kids are brilliant. Once we looked at safety gear, like I brought in helmets and knee pads and things, and I asked them to describe, what does all safety gear have in common? And they said, well, it has a soft part and it has a hard part. The soft part touches you and the hard part's on the outside. And I was like, that's the best description of safety gear I've ever heard. So that's what they did. I gave them soft parts and they had hard parts and they had to build something around their egg. We lost a lot of eggs, but not in the egg drop. They got squished in hands. They rolled off the table. I don't know if you can see, we have upside down lids trying to keep them on the table. But that was the super fun PBL that we did with kindergarten. But all of the eggs did drop successfully once they were wrapped in their safety gear. Here's 2nd grade. Our question here, they were studying geography and landmarks, I think is landmarks. And so this was their first time to ever use a vinyl sticker maker, and they had to learn to weed it. And then they put these stickers up on a giant map in their classroom, and all the students got to make their own stickers, and they put them on various things. They took them home with them after that as well. But they had to do all their research. So I believe all the groups were given a certain place and they had to figure out what was the best icon for that place. And then we turned that icon into stickers. In fifth grade, this was a math and science. It's kind of an experiment, but it was an experiment with digital fabrication. So they were studying irregular shapes and they had to do some estimation. And if in the middle picture, you can see the little L shape and the tiny little cubes on the table, that was, you know, a 1 centimeter square. And then the L was 6 centimeters square. So they had to take some estimations and then design their own thing that would fit in a cylinder that was going to be between 10 and 20 milliliters. So we talked about how centimeters square and milliliters are the same. And so they basically dropped their objects into the cylinders and then would measure the water rise. So that was a really fun sort of combination project where they got to do some digital designing. They then made them on the Prusa's. We learned a lot about, I had 2 different kinds of 3D printers. Not all 3D printers print with the same accuracy. Like that green one was humongous. It did not fit in the cylinder. So they got to do some iteration there. This is moving up to 6th grade. Kids were doing, their 6th grade class is actually English and social studies combined. And so they were looking at technology and early humans. So nothing makes kids happier than making weapons, apparently. So we made weapons by accident. They were supposed to be tools, but apparently all tools are sharp. And they moved through different stages of design by moving through different types of types of iterations. So they started with the paper age. You can see lots of purple paper, so straws paper. Then they could move up to cardboard and they got tape. And then finally, their 3rd iteration, they could use any of the digital fabrication tools, like the little arrows, a 3D printed cone, and they used the ShopBot to make a hatchet. I wouldn't let them sharpen it on the sander. They were a little disappointed, but other than that, seemed to like the process. This, I think it's going to play. So this was, we made earthquake resistant buildings, and yay. So they had to design something that would withstand an earthquake. And I think maybe the most fun was designing the earthquake machine right there, but they did get to create and do a lot of research for that one. In 8th grade, they were studying, well, in algebra, they had to learn slope, and they were studying how to write equations. So they had to start with making equations that somehow resembled Lombard Street. If you don't know Lombard Street, it's famous in San Francisco. It's a very windy street. And so they basically turned their math into a carved street out of a piece of wood. And then we got BBs, and they raced their BBs down the street. And so they were doing math at the beginning, sort of science at the end, and digital fabrication in the middle. So they wound up making their own science project through this PBL. In high school, we've done a lot with physics, and they built some 1-string guitars. And they were studying wavelength and frequency, and they had to measure out where the frets were actually, what are those called? Like little nails. So they had to measure where the frets would go so that they would be able to figure out their total wavelength of their guitar, and then all the frequencies and the notes that they could make. And then if they finished early, they could make a really cool digitally fabricated part of their guitar. So that was kind of neat too, but a lot of science. And they studied electromagnetism because it did have a magnet and copper that's the pickup. So they had to build their little pickup that went in there. In history, the students that year were supposed to create a movie prop for a missing scene from Forrest Gump. I don't even know if we could do this project now. Have kids still seen Forrest Gump? At the time, they all still knew what the movie was. But like these students chose the Lorraine Motel, and they made like a sign that would have emulated what would go outside the hotel. But really what the project was all about was studying American history and things that should have probably been in Forrest Gump's movie. And then this last one, we actually just finished a couple days ago. This is using Turtle Stitch, and I highly recommend Turtle Stitch if you've never played with it, to code math. So this was our high school algebra class, and we were, and when I say we every time, it's because I collaborate with content teachers. So that's really kind of what I do. But they coded their geometrical designs that somehow fit with a quote from their own narrative. So when they were in English class, they all wrote personal narratives. Then they chose a particular quote that they were interested in, and then a symbol that would fit with their narrative. And so here are some of the examples. And I also put a couple pieces of code in there, just so you could see what it looks like, you know, when you're coding for Turtle Stitch. Okay, so sometimes we do projects that aren't only content based. Design challenges, high interest, like we've got students building robots. The little pink flamingo, I wish I had him on video, but we were making accessible buttons for students or anyone who may not have the ability to hit the tiny little on-off switch in his wings, and it dances and does crazy stuff. And then the kids in the upper quadrant are all making just circuits, little rockets that are circuits, learning how to do stuff. I was going to show you this video, but I don't think y'all can hear it. Did you hear anything when the earthquake thing happened? Okay, so I'm going to skip this video, but these are two of my students using physical computing to design an auto-regulated greenhouse. And the microbit is attached. And so basically there's a temperature sensor, and it would open and close the flap to let the hot air out, and it turns the light on and off based on a light sensor as well. But I'm going to skip the video part. Oh, that one was going to play. Do you guys want to hear it? Nah, I don't know. Okay. I'll skip it for now. But you can watch the video if you want to hear them describing what they learned. I guess really, so the way that we have approached content, based maker projects. Michael had a really cool graphic, but this is my teacher brain. So this is kind of what I'm interested in, is that when I come up with a maker project, I know that I need 5 things. I need the content standards. That's always first, because I don't know about you, but school is fast. And if we aren't connected to standards, I can't not connect it to standards. The next part is an open-ended prompt. The kids need to not feel so closed in with what they're making. They need lots of scaffolds and design processes. A lot of folks ask me, are you married to design thinking, or is the engineering design, process? And I say, I don't really think it matters, as long as it fits your students and it fits, what your project is all about. Probably the hardest part is not the materials, but the time and the space, because kid projects go everywhere. So that's something to seriously consider. And then always giving them an opportunity to share out what they're learning, either by creating videos, by presenting in front of other people, whatever it is, they need to celebrate what they've done and what they've learned with other people. And then I added the graphic on the left just because, people say, is it a maker project? Is it tinkering? Whatever. It's whatever it is that you want to call what your students are doing, as long as they're active, right? As long as they are being in kind of control of their learning during the project. The hardest thing is that it's the planning, right? Because you have to do so much planning to get all the things you think they might know or need to know before the project. Not that I need to know how to solve the problem, but I need to have materials and time and thinking about how to set them up for success. But I do think that there's 4 main steps. And so here are my steps. 1 is the good prompt. And the thing that I think makes it interesting, obviously it needs to be clear and concise. They don't need a 12-page prompt, but it should be a little ambiguous, right? If everybody already knows the answer, then we're wasting their time, because I don't want to give them a prompt of something that they already know the answer to. Here's an example. I taught science forever, and the experiments in science class tended to be to reprove something that everyone already knew, that plants need light to survive. And so what do? You stick a plant in a closet and you keep it in the dark for a week. And guess what happens? It dies. It's just awful. Like, why is that a student experiment? There is nothing new to be gained. So one of the things that I think is really important is that we want to motivate them. We want to surprise them. Maybe ask them to build a car that goes the slowest down a hill as opposed to the fastest one down the hill. It's a completely different set of skills that they need to have. So that's kind of, so creating a good prompt. The next one is talking about the standards. And I think Michael may have alluded to this, but the project isn't the icing on the cake. It is the learning. So the student should be learning their standards during their project. So for instance, in the Algebra 1, they were learning all about slope. Well, they started with slope and then they kept having to iterate those equations throughout the project. So first they did it on graph paper. If you've never played with Desmos, it actually graphs your slopes. And then they had to put that information into VCarve, which is then what actually carved it out on the CNC machine. Here are some of the supports. I usually try to think of, like, if there's a client or we're making something for another person, the design thinking process is the way to go, because empathy is so important for students to think about that they're building things for other people. But sometimes they're not building things for other people. They're just making something either for themselves or for some, other process. So we go back and forth between these two processes a lot. And then only grade what's important. I actually think someone in the chat had asked, what about rubrics? Like, what do these things look like? I try very, very hard never, ever to grade their actual project. Like, I would never say, oh, your stitches are wrong. The embroidery machine, messed up your stitches, so you learned nothing. So what I would grade is, what do you know about coding? What can you tell me about math or geometry? That's what I'm grading. So for the greenhouse, what we're assessing is, what did they learn about what plants need? What did they learn about making the microbit move? So for the earthquake challenge, this is actually a clickable link, but if I open it, is it opening so you can maybe see it? Can you guys see that? Okay, good. This is an example rubric. We have this template, and so most of the rubrics I use kind of follow this format. The big standard is at the top, and then it's broken down into learning targets. As far as a rubric goes, on the rubric is just proficient or advanced. If they haven't met proficient, then it's all about a conversation with students, not necessarily, I don't need to write what's not proficient, is what I'm trying to say, on a particular rubric. So you'll notice that each learning target also has proficient and advanced items. And one thing that I think we stress a lot is that advanced is not more of proficient, because doing more of it is a waste of time, but it's moving up Bloom's taxonomy. If proficient is being able to define something, then advanced is comparing and contrasting it. So that they are doing more of an analysis. They are pulling this back into what you want them to know for your standard. And then we always put process skills in the rubric. I need to assess what I think is important. And if I think their communication skills or their creativity or their critical thinking skills are important, then I'm going to put it in the rubric. And then we do have some minimum requirements. Like, I can't grade your building that's supposed to survive an earthquake if you don't make a building. So it's not that it's a 0, it's a nothing until they make it. And one of the things that we stress a lot, or that I stress a lot, is that even if you miss the deadline, that doesn't get you off the hook. That just means that you hang out with me a whole lot as you finish this project on your own time, or as we move through things. And then the grading, that's controversial, and I don't think we want to go into that really, but the grading is pretty basic. Either you did nothing, it was below proficient, or advanced. And that's a STEM school thing. And anyway, so yeah. Okay, so if I click this button, can you guys see my slideshow again? Yay, maybe. Okay, Good. So anyway, so that's just a glance. You guys, we've got 1,000 rubrics, and I'm going to give you some resources for different projects. I think something else that's really important in projects is that the students are assessing themselves and each other, especially as it relates to collaboration, because we're asking them to work in teams. It's what business partners tend to find the most important of the skills for later. And then, but we need to set them up for success there. So before a project starts, students will make a collaboration contract. And so they talk about what they're going to do before collaboration breaks down. And so that's what the top part is. And then they assess each other on the same thing. And I'm apologizing. I don't know why my computer is making all these horrible sounds. I don't know how to turn it off because it's not supposed to do that when I present. I'm so sorry. Okay, so if you're brand new to PBL, these are some of the pitfalls. Is, you know, trying to start a project that's going to take 6 months and not start with a 2-week or a 2-day or a smaller project just to see how it goes. Also, a lot of teachers tend to focus on the outcome, not the process. Again, grading what they learn, not what they make, and thinking that they have to have the answer. You don't have to know what the students are going to make. In fact, it's a whole lot more fun when you're not sure what they're going to make to answer whatever the question is. Cool. Oh, and then more scaffolds. So if you've ever, I don't know, herding cats is the first thing that comes to mind whenever I try to describe what it was like to be a middle school teacher. So having all the scaffolds in the world is something that's really important for students. And I loved these group logs. I totally stole this from Scrum, but made it, I don't know, make more sense for younger kids. And so I print these on huge 11.5 by 14 sheets of paper so that Post-it notes fit in each of the columns. And the students don't actually write on the paper, they write on the Post-it notes, because when they have to-dos all on Post-it notes with initials next to who's supposed to do it, then they can move it to in progress, and then they can eventually move it to done. And it's an easier way to keep track of what's happening with the group and having some accountability, so that if the only things that make it to the done category are one student from a team of 3, then, you know, I know who I need to have a conversation with before they've missed the entire deadline. So we would do that at the beginning of each one. So when they start making stuff, don't forget the safety parts, because, you know, they're using tools they may not have used before. All right, so here's what we're going to do. I'm going to just stop talking because that was 22 minutes or so, and open it up for questions and comments, and I can go back to any of it. But the rest of the slideshow is really just about giving you guys a chance to brainstorm what might you want to incorporate as a PBL into a content class, or how could you support someone else. If you are the lab teacher, or you're the person who knows how to do the maker part, how do you help the content teacher incorporate your ideas, or, you know, making ideas into their particular content class? So if you followed along on the bit.ly, these are all links to these particular documents. Again, I love the iteration. This is a rapid iteration document where it's just real quick. What's the idea? What do you need? Go through 3 iterations and get feedback. Like, how can you very quickly take a raw idea and kind of focus it? And then a little more, maybe not traditional, but the design thinking framework is the next couple little pieces to check on. And I do have blanks that I'm going to share. On the last page here, I just want to give a little shout out, one, to the Invent to Learn book. I think if I hadn't found that book in 2016, I wouldn't be doing what I'm doing now. So yay, Invent to Learn. I may not have the new cover, but these are all clickable links as well. And I can put some of these in the chat. But the Chattanooga Fab Institute happening this summer. I would encourage folks, if you can make it, to come. This particular link, if I click on it, these are all the documents that I've put in a folder to share. So including the what's that called? The slideshow. So if you want any of those, it is there. Also, this link down here is to the website for where I work, but the STEM school has, someone mentioned that they wanted to see rubrics. Well, we've got them. So this is our school website. And then this is not every PBL that we've done in the last 5 years. And it is all high school focused. But if you're interested in knowing what the 9th grade teachers are up to, these are the rubrics that they have created for different PBLs. And I will say this, so our 9th graders do 4 big PBLs per year. And so these have been pretty fleshed out. Anyway, so that's just a resource if you wanted to see more. Also, if you just want to check out the STEM school website, I can't seem to get out of this, but anyway, so I am done presenting per se. What questions do you guys have? And I can make it smaller so that I can see. I don't know if there's stuff in the chat. I haven't seen.
Yeah. So we have a question. Can you talk to cross-discipline across academic classes plus Fab Lab? So the opposite to science/Fab Lab or math/Fab Lab.
Okay, well, yes. I mean, most of what we do at STEM school is cross-disciplinary. I mean, when they do a PBL for 9th grade, there's a piece that's math, a piece that's language arts, a piece that's history, and a piece that's science. It's pretty common. A lot of my examples may have had a science twist just because I taught science for so long, but that doesn't mean it's math and science. In fact, some of the coolest ones I've ever seen have been in history class, like the Forrest Gump projects. I'm not sure if I'm answering your question. Do you mean, is it possible, or does the person who wrote that want to ask a follow-up in case I didn't quite answer?
So they also asked, is there a planning doc where it shows the components of all the subjects?
Oh, yes, actually, let me click on this again. So I included this thing. This is our STEM school PBL unit plan in all of its glory and craziness. So you'll notice that it has a place for a summary, the driving question, which we spend lots and lots of time on putting together, the hook event, and then the scaffolding activities, by the way, I think are pretty important. But if you flip to the bottom, it has the content area, but we would have content area. Wait a minute, where I skipped it. Did I go too fast? Oh, the learning targets. So what we would do is we would have learning targets for every content class. So the learning targets could have math targets, science targets, English targets, etc. So that's kind of where we pull out the other standards for each of those. I wish that my controls weren't exactly where the top of my screen is. Let's go back to PBL really quick, and let me show you one that is already filled out, that has everything. Is 9th grade the best? I know 10th grade does one with the discovery. Let's try this one. Okay, this is the Creative Discovery Museum is a children's museum here in town. And what you'll see, it's very There we go. So in the rubric, it's broken down by what are we doing in math, what are we doing in chemistry, US history, Spanish, and English too. Those are our core content classes that are in 10th grade. And so all the teachers get together that are 10th grade teachers, and they build this PBL together because you can't do it in isolation. We also, obviously, from my examples, I had a lot of examples of just like what we call mini PBLs that are only one content specific. Hopefully that helps some too. But again, I don't know if I'd make that my first PBL because that seems like that would be a nightmare for a first PBL, like when you're doing that. Okay, so what else is in here? I think actually talking about other classes, one of my favorite PBLs that I got to help facilitate was an 8th grade English class. And she really flipped the PBL so that the students were doing their Dig Fab work as a pre-write to their essay, as opposed to doing it after they wrote the essay. So the students had to identify the theme of their essay, and they worked in groups. And then 4 main ideas, and they had to digitally fabricate these ideas. They could make them physical in some way. And although the kids worked in groups to fabricate their 4 main ideas, they all wrote their own essay. So, but it was just a really nice way to get their thoughts kind of processed as what they thought was, I don't know, it was just a really interesting way to get them to then write their essay. And the teacher did let me know that those were some of the most well thought out essays that she wrote or read from her students, because they had gotten to spend the proper amount of time thinking about it before just trying to spill their guts on paper, which I thought was really interesting to have Dig Fab as a pre-write as opposed to the thing at the end. Like, it doesn't always have to be the end of the project, which is interesting.
Oh, we also have another question. How would you answer a response to "they can't do blank until they know blank"?
Are you a math teacher?
I have to prep the student for state testing.
No, I'm just a lot of folks, say, well, how are they supposed to understand all these processes until they know everything? And I mean, does their project have to be a culminating event? That's my question. Like, why can't their project be them figuring it out as they go? And I think, so my personal belief is they are going to learn their content in such deeper ways if they are working through a project that is meaningful than they will if they have to learn it all traditionally before they get to touch anything. Yeah, I mean, that's how I would address that. And the last part, I have to prep the student for state testing. I don't know many schools that do PBL work that are doing terrible at state testing, because it's deep learning, right? Like, the kids are taking ownership of the standards. And I really think it prepares them for state testing, because kill and drill, is that what it's called? Kill and drill? I don't know, whatever. Drill and kill, that's what you're supposed to call it. It just doesn't work for the kids that don't get it. And these are the kids that we want to reach. What else? I don't know. What else do you guys want me to talk about? Let's see. Someone asked about Fabfolio earlier. Was that, do you guys want to see it? I could share what it looks like. I don't know. Yes, please. Okay, so one person wants to see. So let me show you what are sort of some things with Fabfolio are. obviously it's not out there in the world yet. We're out of beta testing, but it's still got some glitching things, but just in general. Yep. Let's see. Okay, so I have kids in a class today. By the way, this is their safety checks. And so they can take safety quizzes on almost every tool we have. We only required 3 of them for this particular thing, but some kids just love taking quizzes, I guess. I'm not really sure what that's about. And this is what we've been up to. So if I look at a student, they were eventually building a light with a microcontroller, but we built them up to getting there. So we were teaching breadboarding, simple circuits, and a lot of other micro credentials. This is, by the way, how I could assess them. I don't want to click on this kid right now, but on their communication, critical thinking, creativity, and collaboration. So I can give them some feedback on their essential skills. And then if they've uploaded evidence, these are the look-fors that we've identified for soldering in particular that would show mastery of maybe not the most beautiful soldering in the world, but hey, I can not burn myself and I can connect some wires, right? So this is sort of some basic ideas. And then the kids upload pictures and they can add captions. We're working on the captions that can further explain what's here. Some kids also do videos of what's happening in the videos. So when they upload their pictures, in fact, some of these you may see are in both sets. When they're working on their breadboard, they're also making a simple circuit, right? So that picture can go for more than 1 microcredential. And then when I spend more time, I'll be able to click these little dots. And if they met all of them, then they would earn that particular microcredential, which is really cool. And then if I hit submit, I don't want to grade this kid's thing right in front of y'all, but because that takes some time. But that's kind of where we're going with stuff. I think what's even maybe more interesting is if we look at the skills that right now in electronics, we've got multiple skills here. So like that's the breadboarding one. This one's all about resistors. This is soldering. So they can see what those look-fors are when they click on the skill tree. So in 3D modeling, we go from basic 3D modeling, like using Tinkercad, all the way where these last 4 would be earning an industry certification in Fusion 360. So we're calling it industrial 3D modeling. And these are literally the look-fors that will prepare them for their test for Fusion 360. So it goes from very simple, right, to pretty darn complex. Like, I'm not sure I could pass the Fusion 360 industry certification right now, which is fine. My students can know more than me. And then they're just broken down into these different categories. We are still just beta testing all of this. So I'm excited to see where this goes. We also have the safety quizzes here where kids can, click on them. And the safety quiz doesn't mean that they know everything about how to use a laser cutter. It just means that they're ready to show me they know how to use a laser cutter. And then, yeah, so that's kind of where we are there. Hey, thanks for sharing that, Michael. Yeah, in safety, having, no. So the safety stuff, I mean, we kind of wrote these, so general safety is don't touch hot stuff or spinning stuff, like in general, and then it gets more and more complicated as you move through. Some of them have exactly 3 questions, like the 3D printer quiz has 3 whole questions. Don't touch the nozzle, don't get pinched by the motors, and that the bed is hot too. So that's kind of pretty simple. But hopefully this will be out there in the world in about a year, 6 months, 8 months. I don't know, something. You're nodding at me. Something like that. So you hopefully will be able to share this with everybody else.